Welcome back. This is Khalid Mustafa Ahmed, and I'm going to continue the previous session about configuring the 389 directory server on our Kerberized Linux network. In the previous session, we have seen how to configure the 389 directory server to include the AutoFS maps info so that the client workstation can read it directly from the server and mount the network file system exported shares. Also, we have seen how to prevent anonymous binding except for the directory server root DSC entry, as well as allowing only secure binding to our directory server. In this session, I'm gonna show you how to configure the directory server for sudo and SUDOers, so that we can centrally escalate any of our LW user permissions to enable him doing some privileged system tasks on some machine or on all machines on our Linux network. Also, I'm gonna show you how to configure Fedora 26 to act as client workstation on our Kerberized Linux network. Okay, let's go and do it. To configure the directory server for sudo and SUDOers, we need first to create an organizational unit for the SUDOer entry right below the directory suffix. Then we need to add a defaults entry just below the SUDOer entry, which include the sudo options. These options could be get directly from your local SUDOer file on your machine. Then use it here with this entry, as we will see in a moment. In this entry, we must include the sudo object class, which contains the sudo option attribute that's used to specify the sudo option here. Also, this object class contain the sudo order attribute, which must take the value of 1 here in this entry. Then you need to add a sudo entry for each user you want to assign a privileged task on some or on all the machines on our network. So we need to create an LD file for that on our home dir and give it suitable name like sudo.ldif file. We start the file. Let's do that. Okay. We need to start the file with a comment, a commented line that specify why we are using it. Enable sudo on our directory server. Okay. Then we need to add the SUDOer organizational unit to this file. We start with the distinguish name, column and space, OU equal SUDOer, comma, DC equal Khalid MA, comma, DC equal local. Then the change type, which must be added here. Then you have to specify the object classes. Object class top object class organizational unit organizational unit, then a description, the sudo ou, then ou SUDOers. Okay. Next we need to add the defaults entry as child entry from the SUDOer organizational unit. As before, we need to specify the distinguish name for the defaults. cm equal defaults, comma ou equal SUDOers, comma dc equal Khalid ma dc equal local, change type also added. We need to add this entry. Object class top, and here we need to add the object class sudo role. Object class sudo role, then a description, this could be sudo defaults, then the common name defaults, okay, then the sudo options, sudo option, and we can get that from our SUDOer else etc sudo here is it, not visible password, exclamation mark here, then enable reset. We have to add this piece here, okay, sudo option, okay, Okay. So we need to copy all the SUDOers options and paste it here in this entry. Okay. And the last one is this option. Okay. Then we need to add the sudo order attribute, which must take a value of 1 for this entry. Okay. We need to add the entries for the users which we want to escalate their permission for doing some privileged system tasks on some machine or on all the machine on our network. So for example, we can give user Tarek the ability to use DNF command to update system packages. For that, we have to specify the distinguish name for the entry, cn equal Tarek, ou equal SUDOers, dc equal Khaled ma dc equal local. Okay. Change type added, change type added. What's up? Okay. Then object class top, object class sudo role, okay. Then the common name for the entry, which is Tarek. Then we need to define the host or hosts on which this user will be able to run this privileged command. Sudo host let be Lenovo dot Khaled ma dot local. Okay. But before that, we need to add sudo user, which is Tarek, sudo user Tariq, sudo host, the host that will be used by this user to run the privileged command. Sudo run is sudo run is sudo run as user. Yeah, it could be all. Okay, sudo run as user all, sudo command. Okay, the command that will be assigned assigned for this user. Okay, user bin DNF. Okay, then we have to give a sudo order for this entry number 2. Okay, and we can edit as many entries for the users here as we wish, then save and exit. Okay, let's add another sudo role for another user. Let be Omar. Okay, Omar, sudo user Omar. And to enable this user to run the tail user bin tail f var log messages. Okay, and give it sudo order number 3. Let's review the file. SUDOers, change type. Okay, this is an organizational unit. Alright, description. This is the defaults entry, which must take sudo order number 1, then a sudo rule for user Tariq, which is already is one of our LDAP users. These users are now given the ability to run the DNF command to update or install or even remove system packages, but only on Lenovo .khalid.me.local. If you want to enable him to use the DNF command on all the machine on our LAN, we can replace the Lenovo .khalid.me.local with the keyword all here. Then the command, the privileged command that's allowed for this user. The second one is user Omar, and change type is added. Object class top, object class sudo role. Okay, common name Omar, sudo user Omar. Then he allowed to run the tail command on this machine, which is Lenovo .khalid.me.local, and must be given sudo order number 3. Let's save this file as sudo.ldiff on our home dir and exit. Then let's go there and and apply this ldiff file. And for that we have to use the ldep modify, the ldep modify command with double capital Z to use TLS. Then we have to bind with tn directory manager with password manager 8123. Alright, and the file we want to apply, which is sudo ldiff, and the entry applied to the server. Let's now open the console and check. Sure. 8123. And double click the directory server and see what happened here. And here is the entry for the SUDOers, and these are the sudo users which we just created and applied to the server by the ldiff file. Okay. Now let's go and configure Fedora 26 as client workstation for our Kerberized Linux network. First we need the following packages to be installed on our machine. Most of it must be already installed on your system by default during Fedora installation, but the reason I mention it here is just in case you miss one or more of it. I prepared a text file that include all this needed package, and as you see it is about the SSD and its client common SSD common pack SSD ldep and KRB5, and also about KRB5 workstation and OS dialog, PAM KRB5, NFSutil, libnss AutoFS and AutoFS, and Cirrus Labs. Also the Open LDAP clients, and all this package must be installed on your system before you continue with this tutorial. So let's go and check that the packages is already installed. DNF install get from Khalid needed packages dot text. Needed packages dot text file. Okay. And the packages already installed on my system. The second thing I want to mention here, with Fedora 26 I prefer to use the KDM login display manager instead of the default SDDM. It's a matter of testing. So I need also to install the following packages, but you are free not to do that if you prefer SDDM. DNF install KDM settings and KDM themes and the system switch display manager. Display manager. Okay. Now to switch the display manager I need to run the system switch display manager command, and from this window I can select KDM instead of SDDM and then click OK, and you have to restart your X server to let the change take effect. But before restarting X, I want to review some the KDM configuration file or KDM-RC under ATC KDE KDM-RC. Then I have to look for the line system shell, okay. This system shell, yeah. By default it is set to bin shell, and you have to replace it to becomes bin bash. Okay, then right and quit. Then you need to restart X. Okay. After restarting X, we need now to synchronize the time at the client machine to the NTP server, the Chrony NTP server running on media.khalidma.local. Remember, we have had configured Chrony NTP server after Kerberized setup at part 2 of this series of tutorials. So all we need to do now is to SSH to media.khalidma.local and copy the Chrony server key from there and use it here with our Chrony NTP client. Then configure the Chrony client to synchronize its time with the Chrony server running at media.khalidma.local. For that we need to SSH first to the server machine, then becomes root, okay, then get the key, the Chrony key from etc chrony.keys. Here is it, and on our client workstation we have to add this key to the Chrony client keys file. Okay, then save and quit. And now we want to edit the Chrony conf, add the client machine, just command the pull line and added server media dot khalid me dot local key number 20, and then make sure the key file line is uncommented. Okay, then you have to restart Chrony at our client workstation. Systemctl restart Chrony daemon, check the status. Okay, nothing abnormal here. Then we have to enable this daemon, enable Chrony D. Okay, so that it will start after reboot. Okay, then you have to check that the client is synchronizing from our Chrony server with Chrony C. With Chrony C tracking, still not. You have to wait some time. And if you check sources, it's reading from our server machine, still not synchronized. Sources state on the server machine. Let's check that Chrony C clients. Yes, it's allowing. Yes, it catch up with the server now. Okay. Yes. Okay. This is a very important step for Kerberos to work at all. Otherwise, you can't authenticate with the Kerberos server and get an error. Okay. I guess it's enough for today, and we will continue in the next session. If you have any issues about this video, please comment me to let me know. Thank you for watching, and bye.